Good afternoon all. Myself Sanal Kumar BG, Faculty Mechanical Engineering. I would like to welcome all of you to the ATAL-FDP on Green Energy Solutions, Building a Sustainable Carbon Neutral World, conducted by Mechanical Department, College of Engineering, Muttathara. Next session is handled by Sri Ayyappadas D on Green Technologies in Mobility. He is working as Principal Engineer, Mahindra & Mahindra Limited, and he has nearly 19 years of experience in diesel performance and emission development, product engineering and verification and support. I warmly welcome Sri Ayyappadas D.
Thanks Sanal for the warm welcome. Thank you Dilip Dal, thank you team. I will take you through green trends in off-road vehicles. So whatever Sanal was telling, my entire career was in diesel engine development. So it is little bit offbeat with the green technology. Whenever we are talking about green, the first main culprit people are thinking is a diesel engine. So whenever diesel is there, people feel the diesel engines are smoky engines. And wherever any emission, any pollution in NCR or any regions are there, the first thing is getting questioned is a diesel engine. You may be knowing the ban of diesel engine in Delhi regions, mainly due to pollution, especially in this winter season. So, but the things are getting changed right now. Lot of changes are happening in off-road vehicles, which are making the engines become more greener. So I will take you through the stuffs. First, I will just take you through what are the different type of vehicle propulsions. You will be knowing that any vehicles need some energy to get propelled, because either it can be an engine, or it can be a motor, anything which is there, because some energy is needed. When I am saying this off-road engines, mainly it is a tractor engines, this construction equipment, wherever it is not going actual on-road or passenger car segments. So, but the concept is same wherever you are taking some on-road or is it an off-road. The concept is similar only the vehicles are getting different. So right now, if you see the major chunk of the technology is using in current on-road or off-road vehicle, there are mainly 2-3 sections are there. One is internal combustion engine. So we can call as ICE. All internal combustion. It can be a diesel, it can be a natural gas, it can be a petrol, or it can be a hydrogen. All these things comes under internal combustion engine. There is a new segment right now. It is getting more and more getting popular. That is hybrid, and other is electric. So these are the major chunk of categories of engines which is used in current vehicles. So just I will give you a brief background what is the major advantage and disadvantage of each one. If you come to diesel, I will go to ICE first. Internal combustion engine, where fuel is mixed in a combustion chamber internally in the engine, and we are getting the power from that one. So the main ICE we are using is diesel or petrol. So this is because if you see in India, almost 95%, not 95, almost 98% of vehicle is either diesel or petrol. So due to main thing, because the infra is already there, because if you see a petrol pump or diesel pump, you can get within some 1 or 2 kilometers. And the availability is not at all a concern. And the technology, whatever we are using, it is there from last 100 years. It is getting evolved from last 100 years. So the technology is there. So everything is there specifically suiting to the diesel or petrol engines. But the major disadvantage is that these engines are emitting a lot of emissions. All this petrol or diesel are hydrocarbons. So when a hydrocarbon is getting burnt, it will give some emissions. So that is one of the major concern of this diesel and petrol engine. Right now, you may be knowing that when a lot of COP25, lot of targets we are putting to reduce the global warming. So these engines are also an important factor for increasing the global warming because of the CO2 emissions. So in worldwide, there is a direction to reduce this ICE engines or reduce the use of petrol and diesel. This is the first one. Second comes to natural or biofuels. These are also hydrocarbons because petrol is also hydrocarbon, biodiesel is also hydrocarbon. But only thing is that this is taken from any plant or any plant derived thing. So if I'm taking a plant derived fuel, so whatever it's like a carbon neutral fuel because I am not whatever the carbon dioxide I am making, but I am taking it back by planting more trees or getting more energy from the nature. So whatever CO2 if I am making, the CO2 is taken by the plant so that we can take as a carbon neutral. So that is one of the main advantage of this natural gas engines. Apart from that, if you see, there are a lot of boost to the agri industry. I think you may be knowing there are a lot of biodiesels like currency oil or oil from Jatropha. All these things are there where these oils are used for internal combustion engines. This will give a good revenue for the farmers. But its major concern is that availability because it is in some pockets. Because all these diesels are in some areas they are cultivating it, but they are unable to make it or brand it because of the infrastructure is not supporting them. If I am having a Jatropha plant or whatever some biodiesel is there, but I should know how to mix with diesel and I should have an engine which will sustain this biodiesel. All these things are there which make it less popular even though it's a good potential is there. To the next ICE engines, this is a new trend whichever is going hydrogen. The hydrogen right now, people are expecting a lot of potential in hydrogen engines. The major advantage of hydrogen is that we are completely eliminating the hydrocarbons from the fuel. If no carbon is there, there won't be any no CO2. So this is simple. Hydrogen, it will oxidize, it will give water, and whatever in the atmosphere, some nitrogen, everything is there, NOx will be there. That you have to control. There may not be any carbonaceous emissions won't be there from the hydrogen. So this is a very promising technology. But here also, this is in a nascent stage. Lot of R&D technologies, research and development is going on there. Here also a lot of infrastructure is required, and handling is a major constraint because we are having a hydrogen cylinder with a pressure of around 300 or 400 bar, and right now there is a new technology up to 600 bar pressure is there. So handling that pressure, that's a major difficulty, and it is highly flammable. So that is also a safety concern. But obviously, a lot of scope is there, and a lot of companies in Europe is also pushing for this technology, especially in trucks and all things. So these are all major ICE engines which we are right now we are either we are following or we are doing some development or some technology research is going on. Come to other section is a hybrid. Hybrid is a mix of ICE engine plus a battery or any other electric source. So this is one of a promising one because here the emissions will be less because partial energy we are getting from battery or any other electric power source. And it is fuel efficient because since I am not putting any fuel, I am taking it from battery. So it is fuel efficient. And one major thing of any complete electric vehicle is that if charging is not available, I have to shut down my vehicle. I can't move it. So here my ICE is there. So it will put us a backup. So the concern of not having any infrastructure or charging infrastructure or charge is going when I am going to a long distance. So that will be completely eliminated in the hybrid. So major disadvantage is that is a cost because I had to meet the emission norms for a diesel engine or petrol. That's a costly one. Apart from that, I had to put a battery and the charging all the steps. So the pollutants are that's one thing. And one more key thing is that even though the pollutants from the vehicle is less, but if I am taking a current which is generated by a thermal power plant, which is using a coal, so we are polluting somewhere in a remote villages and all thing, but my vehicle will be less polluting. So if you see an average pollution, it can be more or less similar. It may not be better as compared to a conventional way what we are following. Then the last or the current boom is for electric vehicle. Electric vehicles, zero emissions. That's the main advantage. Zero emission, no engines, nothing is there. There is no smoke. We don't want to have any tailpipe in the engine. So it's that much clean. So, and operating cost is very less. We know the electric power is cheaper, far, far cheaper as compared to diesel or petrol or any other non-renewable energy. So only the negative thing is that the charging infrastructure is less. And second thing is that the range, because if infrastructure is not there, the range will come into question mark. Because my range of a battery is around some 500 or 400 kilometer, and my charging infrastructure is not there. So all the time I'll be in a risky. If I want to take a car for a 600 kilometer drive or 500 kilometer drive, I will think whether I will get a charging station, how much frequent I can get it. If that station is not working, then what I will do? All these questions will be there. So that make it, right now it's getting popular, but it may take some time. Here also one caveat is there. The pollutions we are seeing from the vehicle only, but we never seeing the pollutions where the electricity is getting generated. So if I am having a thermal power plant with coal and taking electricity and going to a vehicle, so I am polluting in the remote villages where thermal power plants are there. And I am taking it to the car to a city where I'll get a less pollution. So if you see overall pollution, it can be more or less more high, or it can be more or less similar. Only thing it will be very fruitful is that if I am taking an energy from natural resources like hydraulic energy from dam, or a solar power plant, or any windmill, where I am not burning anything. So there, this electric having great future. And here also future is there not from pollution perspective, as in the case of some certain cities. If you see in the newspaper, you may be reading Delhi, a lot of pollution is going out of limit. It's a lot of schools are getting closed due to pollution. So in those areas, this electric vehicle will be a boon to them, because there will not be pollution from the vehicle. So whatever the pollution raised from the vehicle, we can be completely eliminated. So in that way, that will be good. But overall perspective, as long as we are dependent on this coal-based energy, the total emission may not be that much less. But we have to go through the energy sources from natural resources, and this is the future. So this is the general trend of all this vehicle propulsion. Right now, I am taking only to a diesel engine, where a lot of technology is changed. Lot of new technologies are added, which makes the diesel engine cleaner. So I think for the last 2 years, we will be hearing all the other things, the green hydrogen and all the stuffs. But today, since I worked on diesel engine from last 22 years, so I know how it got evolved from emissions, in the emission perspective, from a higher NOx or higher PM. Right now, we are going in milligrams of PM. Whether it was around 400 mg or something like that. Right now, we are going 10 mg, 20 mg like that. So that much we reduced. So just I will take you through the technologies, how the diesel engine, what is the basics of diesel engine, how the pollutions are coming, what are the criticality of pollutions, and what are the current technologies to make it cleaner. So I will just check through what is a basics of a combustion. So combustion is nothing in oxidation. If anything is burning, it is a combustion. If I am lighting a lamp, that's a combustion. That also I'm burning. Fuel is there, and my oxidant, mainly oxygen is there from the atmosphere. And that, under a suitable environmental condition, we will get energy. This is the basics of all the combustion. Whether it is an engine, whether it's a burning, if you are burning something, or you are making something in your kitchen also, if you are switching up the gas stove, same thing only. I am giving an ignition, the gas or something is coming as a fuel, oxygen from the atmosphere, and is getting burnt. The same thing is used, and it should have a proper environment for the proper combustion. So this is the basis of combustion. Assume that all this fuel, whether it's a diesel, petrol, all are hydrocarbons. So there is a carbon and there is a hydrogen with different molecular configuration. And oxygen, that it is completely, combustion means oxidation. If I am oxidizing any hydrocarbon, the result will be carbon dioxide, hydrogen, water, H2O, and energy. This is the ideal combustion. So everything should be fine. There is no other emissions. Only water will be there, water vapor, carbon dioxide will be there, and energy will be there. This is ideal case. But comes to real case, air means not oxygen. Air is having oxygen, 78% nitrogen, hydrogen, water vapor, all the things are there. Once it is getting burned, CO2 will form, H2O will form, energy also will form. Apart from that, some unwanted things are getting also formed. We are saying as a pollutants. Because the nitrogen is there from atmosphere, that also will get oxidized. So that will become NOx. N means nitrogen, O means oxygen. X can be one or two, nitrogen dioxide, monoxide, everything can be. Second thing is that I am burning it, but burning may not be completely proper because something can be unburned will be there. It results in unburned hydrocarbons, smoke, or carbon monoxide. Because if oxygen is there and all the carbons are unable to get the proper oxygen, so something will be as a CO. It may not be completely oxidized CO2. So this is also a pollutant. Right now, recently, you don't know the you will be knowing the criticality of CO because recently in Kerala also, some two guys who was sitting or sleeping in a caravan. So they died due to the CO issue because they started the vehicle and they were sleeping in the vehicle. Due to some leakages in the vehicle, some exhaust gas, something was coming inside, and the CO was coming into the cabin. And after inhaling the CO for a long time, they died. So CO is a silent killer. So all these emissions are highly dangerous to human being because this particulate matter and NOx, nitrogen dioxide, they are carcinogenous things. So it will rise the cancer cases. So we have to control that one. Okay, we are getting energy, we want the vehicle, everything is right. But these pollutants we have to control, otherwise it will be a threat to a future or next generation. So in that case, lot of emphasis or lot of directions are given put by the government to put the emissions under control under various emission norms. You can say BS6, BS5, all these emission norms. The same thing is applicable for all the segments. BS6 and all thing for on-road vehicle. For tractor, it should be TRUM 4, TRUM 3, TRUM 5 like that. Means tractor emissions. And for genset, it could be CPCB2, CPCB3, CPCB4 like that. So all this, wherever if I am putting the engines, it is governed by certain laws which will control the emission of the engine that will maintain a proper clean ambient. And these emission norms are getting stringent and stringent day by day so that our ambient will be clean. So finally, we should have a good ambience, good atmosphere so that our future generation can have a peaceful, healthy life. This is the background of all this emission norms. So this here I am putting what are the emission norms, how it is formed and all things. So the NOx is formed at the high temperature where combustion is good. So somebody can ask a question. Okay, NOx is there. If I am having anything, if I am burning, whether NOx will form or not? No, NOx will form whenever the temperature is going above 1200 or 1400 degrees Celsius. So when a combustion chamber is temperature is there up to 1200 to 1400, obviously nitrogen will react with oxygen forming NOx. But if I want to have a proper combustion, everything is getting burned off. So the temperature will go high because I am having a fuel and I am completely burning it off. So obviously the temperature will go high. So at that time, my emission also, NOx also can go high. So for efficient combustion, NOx will be a byproduct. If I am reducing the NOx by making it little bit temperature down, then my particulate matter, smoke, everything will be increasing. So a combustion development engineer, it's a trade-off between NOx and particulate matter or efficiency and particulate matter because one is counteracting to the other one. So these are the ways which emissions are getting formed in a engine, IC engines. So right now what we are thinking, same thing I'll just put, what are the factors which can impact in the higher combustion? Diesel engine is a heterogeneous combustion. I am putting liquid air in the liquid fuel, liquid diesel, injecting them in an air where it is compressed to certain temperatures so that the diesel will burn. So the fuel, the factors inside the chamber will strongly influence the quality of combustion. So it's mainly the incident temperatures. Depend upon compression ratio, the rate of fueling, fuel injection timing, EGR, everything will define the temperature inside. Then the air fuel mixing, how it is getting mixed. If I am having higher pressure, mixing will be proper. All my fuel particle will get sufficient air to burn it off. The swirl. Swirl means the motion of the air inside the combustion chamber, which will make it all the fuel particles can get a equal amount of oxygen for burning. In the shape of the combustion board, that is also important for proper air fuel mixing. Next is at what time I will inject the fuel, at what rate I will inject the fuel. All these things are impacting the quality of combustion. So a lot of work, if you see from around for last 20-25 years, lot of work is happening in improving this one, improving the bowl shape, improving the injector pressure. Because around 20 years back, maximum injection pressure was around 600-700 bar. Right now, this common rail systems and all thing, it is going up to 2000 bar pressure, fuel pressure. So that my atomization is very huge, so that my emissions will be less and efficiency also will be better. So once this is there, then what are the major pollutants from a diesel engines? So already I explained, first is a nitrogen oxide, NOx. So wherever my nitrogen in the combustion chamber oxidizes with oxygen above 1400 degree, then to form nitrogen oxides. They are toxic gases causing lung diseases. Next is a particulate matter. For a diesel engine, since it's a heterogeneous, so incomplete combustion will create this particulate matter. And here soot particles, heavy smoke particles will be 50% contribution. There are some soluble organic factor, mainly from the hydrocarbons, from the fuel, from the oil, that also will be contributing the particulate matters. So this inhaling all these things, we will have asthma, lung cancer, and other cardio diseases. Next is the carbon monoxide, which already I mentioned the criticality of carbon monoxide. And then the hydrocarbons, incomplete combustion, that will result in hydrocarbons. You may be knowing whenever, because in the case of the kerosene lamp, or whenever we are putting something in our kitchen or something like that, at that time we will have a smell of unburned this one gases, because it is not getting properly combust. We will say a white smoke like that, it is coming from that one. So that is mainly hydrocarbons. That is also a toxic gas. So these are the four emission parameters. Mainly these two are the major critical emission parameters, which is coming from a diesel engines. And whatever I said, particulate matter, how it constitutes, it is having carbon, some fuel derived fraction will be there, oil derived fraction will be there, and some sulfates will be there. Sulfur from the diesel also contribute to the particulate matter. So right now we is gone with what is the different type of propulsion technology, and the diesel engine, how it is working, and with that diesel engine, how the emissions are getting formed. Then the next thing is that how these emissions can be controlled. So we will go for the controlling the emissions. What are different methods for controlling the emissions? So here I will go for two things. One is that base engine hardware. Because if you see, there are two ways to control the emissions. One is the in-cylinder emission, because in the combustion itself, we will control it. So that formation itself is reducing. Second thing is that once it is formed, I will, because there is a limit is there, I can make it zero. Once it is formed, then how I can treat it externally. So that comes in after treatment devices. So the devices we will put it, and we will reduce the emissions from the engine. So if you see basic, because if you say engine cylinder, these are the main. One is the basic engine hardware. Second is a fuel injection system. Second is the air system, because air and fuel interactions creating the emissions and power everything. And some base engine hardware also, like piston ball, friction reduction, low oil carryover. All these things will make the engines better with a low power loss and everything. The fuel injection system, injection pump, injector, and common rail, all these things are new technologies which is reducing the emissions from the system. Once come to air system, air is the right now turbocharged engines are there, intercooled. If you see right now all this petrol engines also, not only diesel engines, it is going with turbocharged. So TSI engine, TDI engine, because that will help in improving the emissions, increasing the more power capacity, everything. And there are some EGR valve, EGR cooler, everything is there to reduce the emission from the engine with the help of air system. So there is some after treatment devices are there called DOC, SCR and DPF, which is critical for reducing the emission from the modern diesel engines. So you may be knowing if somebody is having BS6 vehicles, so you may be facing some issue of DPF is getting clogged, some indication coming in dashboard telling that your DPF is choked. You have to take the vehicle for a drive for some 10 minutes or 20 minutes to clean the filter. Sometimes engine, they will show that when AdBlue levels are low, you have to fill the AdBlue. All these symbols are coming. So don't worry about that one, because in the old cases, these are nothing was there. So emissions were high. Right now, to make emissions under control, all these things are there. To support that system, all these things we need to do it. But by adding the DEF or the AdBlue to make engine with a lower NOx. So this I will just put how is the emission trend, because I am just putting tractor emission trend only between 19 to 37 kilowatt of engines, because these are the major chunk of engines where we are having in India. So if these are different emission parameters, particulate matter, CO, NOx and all things. If you see particulate matter, there are no norms till TREM 2. In 2008, it was around 1 was the value. Right now 0.8, 0.6, right, it's 0.01 PM. So if you see from 2003 to 2025, it's a 2026 edition. With 23 years, the PM is reducing to 99.5%. So that much reduction in the particulate matter, it is there. By emission norms itself, we are putting, government is putting that one. Similar thing for carbon monoxide. From 14, it is coming to 5. NOx from 18 to 4.7. So a drastic reduction in all the emission parameters are there, which forced us, the engine manufacturers, to go for new technologies, and which is a must-be thing to make the clean ambience or clean air. Similar thing for 37 to 56, the same trend is happening. The major trend is above 56. If you see NOx value, which is coming from 18 to 0.4. So putting a 0.4 emission with the in-cylinder engine is not at all possible, or 0.015 PM is not at all possible. There only we are going with this after treatment system like DPF, SCR and all the steps, which make the gas coming from the vehicle clean. This treatment system will treat the exhaust gas and make it clean. So here I am just putting the global trend. It's only to have a reference, because if you only think just I want to emphasize that one. So right now Europe is in this norms and all thing, and we are also at par with that one. With the current TREM 4 and all thing, India is also at par with Europe. So the emission norms are less. It's more or same with Europe. And if you see in US, it is more stringent. In India, it's more stringent than in US. So that's the way our government and our people are also putting more focus in reducing the emissions. This is one more thing is that emissions from the vehicle, because we can test a vehicle in actual emissions. Only thing is that we can test an engine with a cycle which is more or less related to actual in-use cycle. So if you see old cycle was steady state cycle, where we will select some point, rated max torque at different points, and we will take a emission cycle. But due to technology improvement and the more realistic to actual operation, there are transient cycles are introduced. So every second the load as well as speed is getting changed, and the total emissions is getting measured. And also NT is putting that one. So not to exceed is the full form of NT, and NRTC is non-road transient cycle. So all this thing, we can't meet the emission about some certain values at different ambient conditions. Maybe up to 820 millibar also, maybe up to 5,500 feet also, I have to meet the emission. So this much stringent norms are put on place to control the air quality. So right now, just I gone through that emission norms, how our emissions formation norms, but the government is putting input technologies used. Right now, I'll focus on 2-3 major technologies, which is relevant for current engines, which will make the NOx to 0.4 or PM to 0.15 mg and all that. The major or foremost requirement is the high pressure fuel injection system. So around 2000 or 16, about more than 1600 bar is required. Right now, you may be knowing 10 year, 12 year back, certain engines we are putting CRD vehicle like that, common rail vehicle. It was unique at that time because the common rail vehicle having a lot of electronically control, and the vehicle itself is badged with the name common rail system. So that it is a added advantage to them because we'll get a better power, better drivability. But today, we can't imagine majority of 90% of diesel engine is coming with common rail system. Because otherwise we can't meet this emission norms. We want this much of pressure. The common rail system is a completely electronic control system where I can go for multiple injections and it can control the rate of injections. It can control the start of injections. Multiple sensors and actuators are there to control engine at each levels, where it is a high ambient, high altitude, low temperature, everything it is there. So that everywhere it is getting controlled and proper fueling is and proper timing it is done so that emissions will be in minimum. And this ECU also will control the after treatment systems also so that everything will be under one platform. It's a typical common, as a common rail name indicate, there's a common rail is there and the pump is only a pumping element. But when we see, when we are learning through our initial IC engines, we know that when pump will rotate half the engine speed, so that in a four-stroke engine, so that pump will inject the fuel. That concept itself is there, but the pump is not like that. Here the pump will run at any speed. Only the role of pump is to give a pressurized fuel to rail. The injection is controlled by a electronic control unit, which will control the injection at what time, how much, and everything, at how many injection. So that precise control is there. Only all the things are plus point, high pressure, variable pump speed, multiple injections, all the things are there. But only the negative things is the high level of electronics and the cost. These are the two negative things of the common rail system. Any doubt, anyone? Next is the one EGR strategy, because this is to control in-cylinder emissions. You know, because now I already explained NOx is found by a high temperature inside the combustion chamber. So if I reduce the temperature inside the combustion chamber, my NOx will get reduced, but my combustion efficiency also will be reduced. So what we can do is that I can introduce exhaust gas back to the combustion chamber. The two benefits are there. My air content in the oxygen content in that my inside cylinder will come down. But more than that, all this exhaust gases consist of CO2. The CO2, you know, it's a adiabatic and it's a gas which will absorb that thermal conductivity is more. So it will reduce the temperature inside the combustion chamber. To get the 1 degree thermal coefficient is so high so that for raising the one temperature, it will absorb more energy. So inside temperature will come down and it will reduce the NOx. But obviously, if I am reducing that, then my smoke will get increased. At that time, this high pressure common rail system, multiple injection strategy, everything will come into picture to put it back to a lesser PM. So this is a big trade-off happening between NOx and PM in cylinder. It is done by rail pressure and this EGR. The rail pressure, injection pressure, and the EGR. So these are the main in-cylinder thing, because there are some more things like multiple injections and all thing where it is done with the help of this high pressure injection system. Then there's a limit because we can't improve it to a certain limit. After that, I have whatever the gas coming, this will have some emissions. I have to treat it. So one treatment we are doing for PM, CO, and HC reduction is DOC, diesel oxidation catalyst. So we said, because if my hydrocarbons or carbon monoxide, if it is properly oxidized, it will come to carbon dioxide and water. So the same thing I'm using in DOC. DOC is it's an oxidizing agent. It won't do anything. It's a catalyst only. Once it is a catalyst, the platinum or palladium is the catalyst. Once the gas goes through that one, from the oxygen in the exhaust gas will react to CO in the platinum or whatever the catalyst here and convert to CO2 and H2O. So the CO, HC, everything will be there. And in the PM also we mentioned there are some certain factor called soluble organic factor, which is a part of PM. That is mainly hydrocarbon derived factor that will also get burned off. So we will get a PM CO, HC of around 90% reduction. But PM will be around 20 to 30% we can reduce with the help of a DOC. Depends upon the base value also. If the base value is huge, then the 30 may not be possible. But if base value is around some good value, then 30% we can reduce it. But the only thing is that this it's having a PT or palladium or platinum, which is a costly one. Apart from this one, it will convert nitrogen oxide to nitrogen dioxide. Even though my NOx is NO plus NO2 plus NO3, everything is there. So my total NOx, there won't be any change because only NO goes to NO2 only. But this NO to NO2 is very important in the, I will explain in the next slides. Why NO to NO2 is very important. What is the criticality of DOC in this one? Okay, NO, NO2 are not considered separate emissions, but NO to NO2 is very much needed for next after treatment called DPF. Next is I said that particulate matter I can reduce with the help of a DOC, but maximum 30% only I can reduce it. Smoke, I have to, then the next thing is I have to trap it. Assume that if I am having a filter or something is a flow through filter, so every smoke is getting trapped. Then zero smoke will come out from the engine tailpipe. The same thing is called a DPF. DPF is a wall through filter because everything is plugged only. Gas will come here and it moves through the walls by diffusion because it's a porous material, porous coated material like this, and all the smoke particles will get accumulated here. So after a lot of accumulation, because so a soot is a carbon particles. Carbon particles, I want around 550 to 600 degrees Celsius to burn it off with oxygen. But nitrogen dioxide can burn this one at a 300 degree also. About 250 to 300, it will start burning. So my DOC, what I said initially, this NO to NO2, as soon as I am putting a DOC, that will help to burn this soot which is accumulated at a very low temperature without any add. So I, with a 400 degree or 200 to 300 or 300 degree itself, my smoke whichever is getting accumulated here, it is getting burned off by NO2. After that also, because sometimes all the time we may not get that temperature, so it will get accumulate. Then what I will do, I will put a fuel in the DOC, a DOC reactant of DOC, which will get converted into fuel is hydrocarbon, which will get oxidized in the DOC. Oxidation means burning. Temperature will go high. That temperature will be used to burn it here. The oxygen from the exhaust gas and that temperature will burn the carbon particles here. That is called active regeneration. Regeneration means I am regenerating the filter to new one, or it as like removing all the impurities or smoke. Passive is through NO2, no additional fuel is required. Based on the exhaust gas itself, it will get burned. Active is by adding some fuel to raise the temperature. My soot is getting burned off. So like that, I am cleaning the filter. So that's why in any new vehicle, any new diesel vehicle you people are having, or BS6 or like that. So sometimes the message is coming. You go for a regeneration, DPF is fill. You have to do a regeneration. That means that your duty cycles are very less, with low temperature, so smoke is unable to burn it off. So NO2 also requires some temperature, some around 300 degree. But you are taking for 1 kilometer, 2 kilometer. At that time, the gas temperature will be less in the city, because city means no power will be less only using. So all this smoke is getting accumulated. Once it is reaches some certain level, the temperatures are not there to do passive as well as active. Time also won't be there. So in this case, system can't go further because it is almost choked. Then it will show an indication that cluster saying that either you stop the vehicle, go for regeneration. You can do it by running in a highway or something like that. So that temperature will be there to burn it off. NO2 as well as active, we can do that. Or take it to service center, whether they will do some forced regeneration by taking the vehicle's engine speed to some certain level and do that. So like that, we will make it clean. Otherwise, back pressure will go high and it will damage the entire system. So always be careful. Those who are having diesel engines, BS6 and above with the DPF, be careful. Take the vehicle, don't run the vehicle for 1 or 2 kilometers daily. Obviously, the DPF will get clogged. Even though if it is getting clogged, don't get panic. You can do it, clean it by yourself by doing a regeneration. If you can take it to a highway ride for some 10 or 15 minutes, all the smoke will get burned off and it will be like a clean new filter. These are the technologies which we use for PM reduction. So this is a DPF system. Generally, gas will come from here. There is a temperature sensor. There is a DOC will be there. From the DOC, a NO2 will come, and these are DPF. It will get accumulated here, and finally it is getting burned off, and it is exhaust is coming. Just I'm putting an animated one. Assume that the engine is there. My gas is coming. This is getting fully with carbon. Suddenly, regeneration, here is external regeneration is showing. Fuel is getting pumped here. It is getting, you can see, once the fuel is getting injected, that fuel will come here and the DOC, it will temperature will go high and it will burn off the carbon and the filter will be clean. This is the basic functioning of after treatment. Sometimes NO2 from the exhaust gas itself will burn it. Sometimes actively we have to put that one. These are the difference. The soot accumulated. Once it is accumulated, it will go for soot burning with the active regeneration. So I will go for the last one, the NOx reduction. Whatever the EGR and all thing is there, the amount of reduction of NOx is there, but if I want a NOx of around 0.4 grams per kilowatt hour, so I have to go for a exhaust after gas treatment. So this is exactly opposite to DOC. DOC is oxidation catalyst. Nitrogen, how NOx is formed, nitrogen is getting oxidized. So I have to use a reduction catalyst. So SCR is selective catalyst reduction. So I will reduce my nitrogen oxide back to nitrogen and oxygen by putting a SCR with a additional agent called AdBlue or DUF. So this also I'm telling the new diesel cars and the whole thing. Every 10,000 hours or during service, the DUF you have to fill it. It will show DUF level low, DUF indication will be there. DUF means diesel exhaust fluid. Because this legal requirement, I had to meet the emissions. I had to put this one. Then only this will react with the NOx in the exhaust gas in the basis of with the vanadium based or zeolite based catalyst, and it will go to nitrogen and water. Here also temperatures, everything is required, and some injection has to be there. System has to be there. Lines, everything. It's a big complex logic is there. But these are all robust logic, and the DOC also read because NO2 ratio is also important for SCR functioning due to the temperature, because NO2 having a big impact in the speed of the oxidation, speed of the reduction. So a lot of sensors are there. Sometimes because this is ammonia, AdBlue is ammonia based catalyst, ammonia based agent. So it is converted to ammonia, and that ammonia is reducing this nitrogen dioxide. Sometimes what happens, some ammonia can slip from the engine. So ammonia is also a toxic gas. So we are putting a slip catalyst to oxidize the ammonia back to nitrogen and water. There's a complete system is like a thermal factory. If you see that one, this will be the SCR. AdBlue will be those. AdBlue tank will be there. AdBlue controller will be there. From the tank, it will come here and put those that one. Here SCR catalyst will be there. Here the conversion will happen, and it will come. There's a slip cat also is there to convert the extra ammonia which is getting slipped from that one. These are the engine structure and all for that. These are all from my side for the emission control strategies and make the diesel engines greener. So any doubts, any questions you are having? If I'm knowing right now, I will share the answer. If I'm not knowing it, I will come back to. I will share the answer to the lead log so that you can get the answers. Feel free to ask.
Any questions from the participants? Any questions, sir?
Okay.
Okay, sir. Thank you, sir. Thank you for this wonderful session. And your session has given the audience a deep understanding about the various green technologies used in the mobility for achieving a sustainable clean energy and carbon neutral world. Thank you, sir.
Thank you, Sunil. Thanks, Steve, for inviting me for this talk. Thank you very much, and wishing you all the best wishes and a happy new year.
Thank you, sir. Thank you. Thank you for this.
Thank you. Bye bye.